Okay, so now let's look at another section which is infinite limits. So let's say we have a function of fx equal to 1 over x squared. So graphically, the shape of the graph for this function is like this. Okay, so we can hear that, we can not hear it, we can see that fx becomes very large as x approaching 0 from both sides. So as x approaching 0, x is becoming very, a function is becoming very large as x is approaching 0. So means dekat sini adalah infinity, is going towards infinity. Okay. Okay, we want to find limit x approaches to 5 over x minus 2. Okay, so now we will try to do it on both sides. So limit x approaching 2 from the right side, f over x minus 2, and limit x approaching 2 from the left side, 5 over x minus 2. So when we substitute the value is 5 over 2 minus 2, we have 5 over 0, so it will be equal to positive infinity. So yang bawah ni pula, we have 5 over 2 minus 2 equal to 5 over 0 equal to negative infinity. So yang ini adalah sama dengan negative infinity. So kenapa dia sama dengan negative infinity? Because x is approaching towards 2 from the left side. So kalau kita tengok daripada belah kiri, 2 kita ada 1, kita ada kosong. So kalau datang daripada belah kiri, bermaksud nombor dia adalah less than 2. So any number less than 2 minus 2 will give you a negative value. Kita boleh, contohnya kita boleh letak negatif kat sini. So that's why when 5 divided by 0, that is coming from the left, lepas tu dia akan jadi negative infinity. So kalau yang x is coming towards 2 from the right side, kalau macam ni, 2, 3 and 4, x is coming from the right. So all of this number that is right side of number 2 is much bigger than number 2. So when number bigger than 2 minus 2, it will give you a positive 0. So that's why 5 over 0 give you a positive infinity. So another example is to find limit x approaching 0, 3x over x power of 3. So then we have limit x approaching 0 from the left, from the right, and we have limit x approaching 0 from the left. So then we have 3x over x power of 3 and also 3x over x power of 3. So x can be divided, so we are left with 3 over x square equal to 3 over x square. So we substitute the value of 0, 3 over 0 positive square, so equal to 3 over 0 negative square. So yang atas akan bagi positive infinity dan yang bawah pun akan jadi positive infinity, because sebabkan kita ada square dekat sini, so dia akan jadi positive. Square untuk negatif, so negatif jadilah positif. So we have contoh yang lain, limit x approaching 4 to x over x minus 4. So kita ada limit x approaching 4 from the right to x over x minus 4, and limit x approaching 4 from the left to x over x minus 4. So equal to 2 4 over 4 minus 4 equal to 8 over 0 yang positif. So akan equal to positif infinity. So yang ni pula 2 4 over 4 minus 4 equal to 8 over 0 yang negatif equal to negatif infinity. So bila dia tak sama, maksudnya function limit ini does not exist. So let's look at another one example. We have limit x approaching 3 of 2x minus 4 over 3 minus x. So kita pecahkan dia dulu pada limit x approaching 3 from the right to x minus 4 over 3 minus x, and limit x approaching 3 from the left to x minus 4 over 3 minus x. So dekat sini kita akan dapat 2 3 minus 4 over 3 minus 3, so equal to 6 minus 4 is 2 over 0, tapi sebabkan 0 x ni adalah yang di belakang, so 3 minus x, so 3 minus any number that is bigger than 3, so kita akan dapat 0 yang negatif. So sini akan jadi negatif infinity. So 2 3 negative 4 3 minus 3 equal to 2 over 0 yang positif, because this limit x is approaching towards 3 from the left side. So left side means number is less than the number of 3, so that's why dia jadi positif. So equal to positive infinity. Okay. Now let's look at next section, which is limits at infinity. So tadi lain tadi itu adalah infinite limits. So infinite limits, kalau kita tengok balik semula, infinite limits tu kita limit dia adalah a number, a real number lah. So means 0, 3, 4 tadi contohnya. Tapi bila kita tengok limits at infinity, situasinya akan jadi berbeza. Di mana limit x is approaching towards infinity, bukannya approaching towards any real number. Okay. Okay, so let's say I explain based on graphically. So let's say we have two graph. Bentuk dia macam ni. Okay. So this is y, this is x, y and x. So untuk yang pertama ini, so let's say label ini satu, ini yang kedua. So let's say limit x is approaching negative infinity and the function is x power of 3. So kita akan, dia akan jadi when limit is approaching towards negative infinity. So bermaksud kita akan pergi ke towards negative infinity. So kita akan dapat negative infinity sebab dia kuasa 3. Kalau dia kuasa 2, dia akan jadi positive infinity. So let's say if we have limit x approaching positive infinity of x power of 3, so that akan equal to positive infinity. Jadi positive infinity. Okey, kalau daripada graf awak boleh nampak apabila x menghala ke positive infinity, value of y akan naik ke atas towards positive infinity. So when x is towards or approaching negative infinity, the value of y decrease towards negative infinity. Ini yang diwakili oleh mereka. Okay, kalau yang belah kanan pula, let's say we have limit x approaching negative infinity for negative x power of 3. So yang ini akan jadi positive infinity. So kita boleh tengok dari sini, when x approaching negative infinity, y akan naik menjadi positive infinity. So when limit x approaching negative infinity, positive infinity of negative x power of 3 akan approaching negative infinity. Okay, now let's look at the example. Let's say we have limit x is approaching towards positive infinity of function x square plus 3. So bila kita substitute, infinity square plus 3 akan sama dengan positive infinity. Example yang lain, limit x approaching negative infinity of 1 minus 5 over x. So ini bila kita masukkan negative infinity kat bawah ni, so macam 1 minus 5 over negative infinity. So 5 over negative infinity is equal to 0. So dia akan dapat jawapan 1 plus 0 equal to 1. So let's say limit x approaching positive infinity of 2 over x minus 3 power of 3. So sini kita ada 2 over infinity minus 3 power of 3. So akan sama dengan 2 over infinity. So it is equal to 0. And let's say limit x approaching negative infinity of 9 minus x. So equal to 9 minus negative infinity. So akan jadi positive infinity. So 9 plus infinity is infinity, and square root of infinity is infinity. So limit x approaching positive infinity, 1 over square root of x equal to 1 over square root of infinity is still equal to 0. Alright, and then pergi kepada contoh lagi, iaitu contoh yang pertama, limit x approaching negative infinity of function x square over 7 minus x square. So kalau kita substitute negative infinity square over 7 minus negative infinity square, so kita akan ada infinity over 7 minus infinity. So sini kita akan ada infinity over negative infinity. So ini tak boleh diterima. So just like yang kita buat factorization dengan asymptote tu, infinity over infinity ataupun 0 over 0 is not acceptable. So what we do is we need to adjust sikit, sama macam tadi. So bila kita ada x dengan x ya, kita ada faktor yang mana numerator ada x dan denominator pun ada x. So what we do is we divide both numerator and denominator with the highest power of x in the denominator. Okay, kita bahagikan dengan x yang berkuasa paling tinggi pada denominator, iaitu x square. So kita ambil x square atas bahagi x square over 7 over x square minus x square over x square. So ini akan jadi 1 over 7 over x square minus 1. So sini akan jadi 1 over 7 over infinity minus 1. So equal to 1 over 0 minus 1 equal to negative 1. So ini barulah jawapan yang betul. Okay, contoh yang kedua, we have limit x approaching negative infinity of function x power of 4 minus x over 3 minus 2x. So kalau kita substitute directly negative infinity power of 4 minus negative infinity over 3 minus 2 negative infinity. So kita akan ada infinity plus infinity over 3 plus infinity. So kita ada infinity over infinity. So this is not acceptable. So apa kita perlu buat adalah bahagikan pecahan ini atas dan bawah dengan kuasa x yang paling besar di bawah. Tengok, paling besar di bawah adalah x kuasa dengan 1, x power of 1. So x approaching negative infinity, x power 4 over x minus x over 3 over x minus 2x over x. So kita akan ada x power of 3 minus 1 over 3 over x minus 2. So then we have negative infinity power of 3 minus 1 over 3 over negative infinity minus 2, and then we have negative infinity minus 1 over minus 2, and then we have negative infinity over negative 2. So then we have equal to positive infinity because negative over negative. So now for number 3, example number 3 is limit x approaching infinity of function x square over 5 minus x power of 3. So limit x approaching infinity is x square over x power of 3 over 5 over x power of 3 minus x power of 3 over x power of 3. So we are left with 1 over x power of 2, 1 over x over 5 over x power of 3 minus 1. So then we get here is 1 over infinity over 5 over infinity minus 1. So 1 over infinity is 0 over 5 over infinity is 0 minus 1. Then we get here is 0. So for question example number 4 is limit x approaching infinity of 2x plus 1 over square root of x square plus 3. So kalau macam ni, kita masih lagi bahagikan dia dengan power of x yang paling besar di bawah. Paling besar di bawah adalah square root of x square. Okay? Yang square root tu jangan tertinggal. Ramai orang yang tertinggal, dia ambil x square sahaja. Tapi kita tengok bahawa itu adalah square root of x square, iaitu sama dengan x. Jadi kita akan buat dia jadi macam ni, 2x over x plus 1 over x over x square plus 3 over x square. Okey, yang bawah kita masihkan kekal ambil x square, tapi kita akan masukkan dia ke dalam square root. So dia maksudnya dia masih lagi x power of 1. So yang ni akan jadi 2 plus 1 over x over square root of 1 plus 3 over x square. So dekat sini kita akan ada substitute dia punya value of infinity. So 2 plus 1 over infinity over square root of 1 plus 3 over infinity. So 2 plus 0 over square root of 1 plus 0. So then we have 2 over square root of 1 equal to 2.